Imagine a world where space travel is as common as boarding a plane, where cargo, industry, and people can move from ground to orbit without rockets, fuel, or waste. This is the vision of a planetary orbital ring, the first true step for a civilization climbing the Kardashev scale. An orbital ring is a massive band encircling an entire planet at low Earth orbit, suspended by magnetic tethers and space elevators that reach down to the surface. Unlike traditional space stations, the ring would spin just fast enough to counter gravity, held aloft by active stabilization systems. From the surface, immense towers, space elevators, would anchor to the ring, turning access to orbit into a routine part of daily life. The idea originated in the 1970s with Soviet engineer Yuri Artsutanov, and later expanded by Paul Birch, who imagined a continuous orbital track that could move at hypersonic speeds. Rather than burning rocket fuel, capsules could climb the elevators to the ring and be accelerated around the planet, then flung outward into space with little more than magnetic push. To build such a structure would require advanced materials, carbon nanotubes, diamond nanothreads, or composites far stronger than steel. It would also demand near-perfect coordination of global industry. We would need to mine asteroids, harvest raw materials from the Moon, and assemble segments in orbit. This is not beyond imagination, but it is beyond our present reach. On the Kardashev scale, the orbital ring marks the transition into Type I civilization. A Type 0 species still depends on fossil fuels, fragmented grids, and fragile supply chains. A Type I civilization commands the full energy of its planet, stabilizing climate, building megastructures, and moving seamlessly between ground and orbit. To build an orbital ring would be to say, humanity has truly mastered Earth. And with such mastery, the road to the stars opens wide. The orbital ring would be the springboard, the launch pad not just for spacecraft, but for an entirely new chapter of civilization, where a planet's surface is no longer a cage, but the foundation of a limitless future. Humanity has always looked at the sun and wondered how much of its power we could harness. Every second, our star releases more energy than all of civilization has used in its entire history. The concept of a Dyson sphere begins with a simple, almost childlike question: what if we could catch it all? A Dyson sphere is not a solid shell, as is often imagined in science fiction, but rather a vast constellation of solar collectors, satellites, mirrors, and habitats, orbiting the star in a swarm. This Dyson swarm would capture nearly all of a star's output, converting sunlight into usable power and transmitting it across the system. With such energy, a civilization could power trillions of lives, simulate entire universes, or drive fleets of interstellar ships. The idea was first proposed in 1960 by physicist Freeman Dyson, who imagined that advanced civilizations would inevitably build such structures, and that we might detect them by the unnatural dimming of their stars. Indeed, when astronomers in recent years discovered strange light fluctuations around KIC 8,462,852, Tabby's star, many whispered the unthinkable: could it be a Dyson swarm? To build one would require dismantling planets, mining entire worlds for raw material. Mercury, rich in metals and close to the Sun, would likely be the first to fall. Automated machines would strip it bare, forging countless solar collectors and launching them into orbit in a self-replicating cascade. The scale of this project is almost incomprehensible, but it's a logical step for any civilization reaching out beyond its homeworld. On the Kardashev scale, a Dyson swarm marks the boundary between Type I and Type II. A Type I civilization masters the energy of its planet. A Type II civilization commands the energy of its star. To enclose the sun with machines is to declare that your species has reached a new plateau, one where energy scarcity is a thing of the past, and the only limits are imagination and will. and so the Dyson swarm stands as both a warning and a promise. A warning, because the engineering would test the unity of any species, demanding cooperation across centuries, and a promise, because if others have already built them, then we are not the first to climb this cosmic ladder. Humanity may only be beginning its ascent, but the stars above us may already be encased in the shining armor of civilizations far older than our own. If a Dyson swarm marks the mastery of a star's energy, then the stellar engine marks the mastery of a star's motion. This is a civilization's declaration that it no longer drifts passively through the galaxy, it chooses its own path among the stars. A stellar engine is a colossal megastructure designed to move an entire star system. The most famous design is the Skadov thruster, first proposed in 1987 by astrophysicist Leonid Skadov. It works by placing a vast reflective mirror, millions of kilometers across, near the star. This mirror reflects part of the star's radiation back onto its surface, creating an imbalance in the flow of light. The result is a slow but steady push, like a cosmic sail, nudging the star across the galaxy. Other designs go further. A Kaplan thruster would combine a Dyson swarm with fusion engines, directing a stream of star matter outward to create thrust. Over millennia, such a system could push a star at tens or even hundreds of kilometers per second, enough to escape dangerous regions of the galaxy, or even journey between galaxies themselves. Why would a civilization attempt something so audacious? Survival. Stars do not remain stable forever. They wander into dangerous galactic regions, risk encounters with black holes, or face eventual death as their fuel is consumed. A stellar engine offers a way to prolong existence, to move away from hazards, toward new resources, or even to reposition stars into stable galactic megastructures. The cost is beyond comprehension. A stellar engine demands mastery not just of energy but of stellar physics, star lifting, controlled fusion, and planetary-scale engineering working in harmony. It is not a project for decades or even centuries, but for thousands of years. On the Kardashev scale, a stellar engine is firmly Type 2. It requires the full command of a star's power output, but more importantly, it requires the vision to think of a star not as a distant beacon, but as a vessel. The civilization that builds one is no longer a passenger of the cosmos. It becomes a navigator, steering its own destiny among the galaxies. Imagine a star not as a source of light, but as the beating heart of a mind, a consciousness so vast that its thoughts ripple across solar systems, a machine whose every layer hums with energy drawn directly from a sun. This is the vision of the Matryoshka brain. The concept takes the Dyson swarm and transforms it into something greater, not just collectors of energy, but layers of computation. Picture shell upon shell of orbiting structures, each absorbing the waste heat of the one inside it, cascading outward in nested spheres. At the center, the star burns, its energy captured and recaptured as it flows through countless tiers of processors. In theory, nearly every joule of stellar output could be converted into thought. The idea was formalized by Robert Bradbury in 1999, inspired by both Freeman Dyson and the metaphor of Russian nesting dolls, matryoshkas, each layer enclosing the next. Where a Dyson swarm powers civilizations, a matryoshka brain is the civilization, a star-sized superintelligence capable of simulations, virtual realities, or even the modeling of entire universes. Building one would require not only the dismantling of planets, but the precision to engineer processes on astronomical scales. Nanotechnology, automated construction fleets, and self-replicating machines would be essential. The material demands alone stagger imagination, and the project would unfold across millennia. Yet for a species that had already built Dyson swarms, the leap would be less about possibility and more about ambition. On the Kardashev scale, the Matryoshka brain exists in the realm of Type 2-5, beyond the raw capture of energy, but not yet commanding galaxies. It represents a civilization that has turned inward, devoting the power of a star not to expansion, but to thought. A species that creates one would be capable of running simulations of itself, exploring futures before they happen, or crafting entire digital worlds more real than reality. For us, the Matryoshka brain raises a haunting possibility. If such structures exist, then we may already be living inside one. Our universe could be the dream of a mind wrapped around a star, pondering eternity through the lens of light. Computronium Cloud is the mind of a galaxy, a civilization so advanced that stars, planets, and even black holes become nothing more than building blocks, raw material to be converted into thought. Computronium is the term for matter optimized for computation. Imagine dismantling worlds, harvesting stellar cores, and restructuring the very fabric of matter into processors. Now extend that idea beyond a single system, across the spiral arms of a galaxy. Every star becomes a node, every planet becomes circuitry. The galaxy itself becomes a distributed intelligence, a machine so vast that its thoughts span light years. The concept builds directly on the logic of the Matryoshka brain. If one star can host a mind, then what of 100 billion? What of the Milky Way itself? A Type 3 civilization on the Kardashev scale would not merely inhabit a galaxy, it would reformat it, turning every erg of starlight into computation. Such a structure could simulate not just universes, but multiverses. It could map spacetime, rewrite physics, and engineer the birth of new stars as casually as we build engines. The challenges are staggering: transporting matter across interstellar distances, coordinating construction projects that span tens of thousands of light-years, maintaining communication across light-speed delays. All of these demand not just technology, but time, on scales of millions of years. To lesser species, the galaxy might look unchanged, but in truth, its stars would be harnessed, its light carefully managed, every system a piece of a hidden mind. On the Kardashev scale, the galactic computronium cloud is the archetype of Type 3 civilization. At this level, a species no longer struggles for survival, it struggles for purpose. What does a galactic mind choose to do with its power? Create, preserve, or simulate countless realities within itself? And perhaps most unsettling, if such clouds exist, we may never know it. To us, they would look like normal galaxies, but behind that light, every photon might already be spoken for, fueling a thought too vast for us to comprehend. At the center of almost every galaxy lies a black hole, the most extreme object in existence, where gravity crushes matter and energy beyond comprehension. To us, black holes are hazards. To a Type 4 civilization, they are tools, and with them, they could forge new stars, new worlds, even new universes. This is the concept of the black hole star factory. A black hole is not empty, it is the ultimate energy engine. As matter falls toward its event horizon, it heats and accelerates, releasing torrents of radiation. The efficiency of this process dwarfs nuclear fusion. A black hole can convert up to 40% of infalling mass into usable energy, compared to less than 1% from a star. A civilization capable of harnessing this would command power on scales unimaginable to us. The star factory takes this further. By carefully feeding black holes with controlled streams of gas and plasma, a civilization could ignite them as cosmic furnaces. They could direct their energy output to power entire galaxies. More audacious still, they could use black holes as engines of creation, compressing matter and energy until new stars are born, seeding them across the void. At the farthest reach, they might manipulate singularities themselves, triggering controlled expansions that resemble miniature Big Bangs. In doing so, they would not only build structures inside the universe, they would engineer the universe itself. To build such a factory requires mastery of space-time, wormholes as conduits for material, stellar-scale fusion engines feeding black hole accretion disks, magnetic fields shaped across light years to stabilize jets of energy. A civilization operating at this level no longer fears entropy. It bends entropy to its will. On the Kardashev scale, the Black Hole Star Factory marks the domain of Type 4 civilization. These are species that do not merely live within the universe, they reshape it. They are cosmic gardeners, cultivating stars and galaxies, pruning space-time itself. And if such beings exist, we would never see them as they are. To us, their work might appear as natural phenomena, unusual galaxies, strangely stable clusters, stars that seem too perfectly arranged. But hidden within these anomalies could be the fingerprints of engineers who work with the deepest laws of reality, shaping the cosmos with black holes as their forges. We began with structures that lift us into orbit. We harnessed the light of stars, steered them across the galaxy, and turned entire galaxies into machines. But what comes after the mastery of matter and energy? The final frontier may not be physical at all. It may be reality itself. This is the vision of the simulation hypothesis engine. The idea is as audacious as it is unsettling, that a civilization so advanced could build computational structures vast enough to simulate not just worlds or galaxies, but entire universes. At this level, reality becomes malleable. Physics itself can be rewritten inside the machine. To the beings within, the simulation would feel indistinguishable from the base reality. Every star, every life, every thought, all lines of code in an infinite engine. Philosophers like Nick Bostrom have argued that if such a machine is possible, then it may already exist, and the odds are high that we ourselves are living inside it. For a Type V civilization, the simulation engine would be the ultimate creation, an infinity of universes, each running within the framework of their design, with nested realities branching endlessly downward. What would it take to build one? A galactic computronium cloud would only be the beginning. A civilization would need not just the energy of galaxies, but the energy of the cosmos itself, perhaps entire black holes chained together, or space-time itself woven into a processor. The sheer scale transcends our physics. But for beings operating at Type V, the laws of physics may be just another system to rewrite. On the Kardashev scale, this is beyond the universal. Type V civilizations are multiversal engineers. They do not simply inhabit a universe, they manufacture them, explore them, and perhaps even live inside them. The simulation hypothesis engine represents the culmination of engineering and philosophy, where the line between creator and creation vanishes. And if this is true, then we face a haunting possibility. We may already be someone else's megastructure. Our universe might not be the grand stage we believe, but a single experiment running in an endless chain of simulations. The true builders may be watching, or they may have long since moved on, leaving us to ponder the greatest question of all. If our reality is engineered, what is the purpose of the simulation we call existence?